Today we're going to be learning about how to subtract rational numbers. So rational numbers include integers, decimals, and fractions. So today's learning target, again, is just simply I can subtract rational numbers. So if you recall, we can rewrite any subtraction problem as an addition problem. And when I mean as an addition problem, meaning that it's an equivalent addition problem. And we do so by doing something called adding the opposite. So you can think about keep, add, opposite. Other people do keep, change, change, keep, add, change. A lot of different ways to say it. I like to say keep, add, opposite to remind ourselves that we're adding the opposite. And so the first step would be to keep the first number the same. Add meaning change the subtraction sign to addition. And then that opposite means that you're going to change the sign of the second number to its opposite. So when we go to subtract rational numbers, we're going to first convert them to addition problems. And then we're simply just going to follow the rules for adding integers. So as a reminder, the rules for adding integers, when we go to add integers, there are two kind of sets of rules of when we're adding numbers with the same signs versus adding two numbers with different signs. So when we're adding numbers with the same signs, we're essentially just adding the absolute value of the numbers, and then we're going to keep the sign of the answer throughout the problem. So if you're adding two negatives, the answer is negative. If you're adding two positives, the answer is positive. If you're doing different signs, you're going to subtract actually the two numbers or the absolute value of the two numbers, and then the sign of your answer is going to be whichever number is further away from zero. So let's kind of look at all of those rules into action. So the first thing we're going to do in the example is we're going to take each of these problems and we're going to keep, add, opposite for all of them, meaning we're going to convert all of these subtraction problems to addition problems. So the first problem is negative 11 minus negative 4. So that's going to become negative 11 plus positive 4. And B, I'm going to keep negative 9, and then I'm going to add the opposite. So it would become negative 9 minus 12, it would become negative 9 plus negative 12. And then we have, in C, we have 4.5 minus 5.3. So it's going to be 4.5 plus negative 5.3 when I do my keep, add, opposite. And then my fraction would be negative 4 plus negative 3/4. Okay. So let's look back at A, and we're going to solve them using our rules for adding integers. So in A, I have negative 11 plus 4. So that means that I have different signs. So I'm going to actually subtract. So the difference between 11 and 4 would be 7. And then my answer is going to be negative 7 because 11 is farther away from 0 than 4. That would be my answer to both the subtraction and the addition problem. So remember, they are equivalent problems. One's just a subtraction sentence, one's a addition sentence. If we look at B, we have negative 9 plus negative 12. So these are actually the same signs. They're both negative. So I'm going to add negative 9 plus negative 12. 9 plus 12 is 21. And that would be negative 21 because I'm adding two negatives with the same sign together. In example C, I have two numbers with different signs. So I'm actually going to subtract them. So I'm going to take my larger number, meaning the larger one that's further away from 0, which is 5.3, and I'm going to subtract 4.5 from it. Okay, so depending on how you like to subtract, I'm going to get 0.8. And my answer is going to be negative because, as I just mentioned, negative 5.3 is further away from 0 than positive 4.5, so the answer to my problem is going to be negative. And then if I look at my last example, my fraction 1, I'm adding two numbers with the same signs, so my answer is also going to be negative. So if I have negative 1/4 plus negative 3/4, when I'm adding these fractions, they have the same denominator, common denominator. So I'm going to just look at the top and add my numerator. So I have -1 plus -3, which is -4/4. And that can simplify to just -1. So now we're on to the we do section. So we're going to be doing a lot of these together. So I'm going to go ahead and convert the first two to addition problems to give you a couple more examples of how to do that keep, add, opposite. So let's look at the first example. We're going to keep the first number the same, add meaning change subtraction to an addition sign, and then change the sign of the second number to its opposite, which would be +15. For number 2, keep, add, opposite, keep the sign of the first number, which is -9, and then I would add the opposite. So instead of subtracting +9, I would add -9. So what I'd have you guys do right now is go ahead and pause the video and then try doing the next 3 through 8, meaning just convert them to addition problems first. Okay, so here are all the problems converted to addition sentences. So why don't you can pause the video and double check that you converted them all correctly before we dive into actually subtracting or adding the numbers. So now we're going to actually just look at the addition number sentences and use those rules that we talked about before about whether they're the same signs or different signs. I'm actually going to go ahead and circle the ones with different signs in pink, and then I'll go ahead and do same signs in purple. So again, I'm looking at the addition sentences. So 2 plus 15, that's the same signs, same signs. It looks like number 6 and looks like just number 6. And then the rest of them should be different signs. The same signs, remember I'm adding normally. So 2 plus 15 is 17. So the answer to both of those would be +17. And number 2, -9 plus -9 would be -18. And then I'm going to jump to number 6. I have -1 plus -10, which should also be -11. So again, I'm just adding normally and keeping the sign of that number. So if I go back to the rest of the problems, those are all different signs, meaning I'm actually going to subtract and then take the sign of the larger number. So -12 plus 13 would be +1, because 13 is further away from 1. 3 plus -14 would be -11, because 14 is further away from 0 than 3. And number 5, the difference of 7 and 4 is 3. And my answer would be +3 because 7 is farther away from 0 than -4. In number 7, I have 6 plus -16, which would be -10, because 16 is further away from 0 than 6. So the answer would be a negative sign. And my last answer would be +14, because 17 is further away from 0 than 3. So if you look at the second half of your page, we have decimals on one side and fractions on the other. So we have just a couple more examples to get through. So how I'm going to go about doing these again is going to be keep, add, opposite. I'm going to change all these subtraction problems to addition number sentences. So if you want to pause the video and try it on your own, and then we'll be able to check our answers together in just a minute. Okay, so double check that you converted all your problems correctly to correct addition number sentences. Then we're going to go ahead and solve them. So in number 9, I'm adding two numbers with the same sign, meaning I'm just going to add normally. So if I need to, I can write them kind of stacked on top of each other off to the side. I know I'm just adding them, so I'm ignoring their signs, meaning I'm just taking the absolute value of them. Your decimal should be lined up when you're adding decimals as a reminder, as well as your place values. So 2 plus 5 is 7. 7 plus 3 is 10. So my answer should be -10.9 because I'm adding two numbers that have negative signs. In number 10, I have negative 0.5 plus 5. So I have two numbers that are different signs, meaning I'm going to subtract. So when I subtract, I'm doing 5 minus 0.5. You can write off the side, but essentially you'll get 4.5 as your answers, and it would be a positive 4.5. Think about you have $5, and then you're taking 50 cents away. And number 11, again, different signs, so I'm going to go ahead and subtract. So I'm going to stack my answers and subtract. Again, I'm going to use the larger number on top, meaning the one that's further away from 0. 9 minus 6 is 3. 7 minus 2 is 5. Follow my decimal down. My answer here is going to be negative 5.3 because 7.9 is further away from 0 and it's negative. So when we go and do fractions, it's the same thing. I'm adding two numbers with the same sign and common denominators. So if I have negative 2 sevenths plus negative 5 sevenths, I'm looking at my numerators. Negative 2 plus negative 5 is negative 7. Negative 7 sevenths is negative 1. If I look at 13, I have 1 1/3 plus 1/3. You could convert your mixed number to an improper fraction and go that route. You could also see that I have 1 1/3 plus 1 more third. So that would just give me 1 2/3 as my answer. I forgot to write these with the subtraction problem. And then my last example, again, I have common denominators. So I'm talking about 16ths, but my numerators are 11 plus negative 15. They're different signs. So I'm going to actually subtract. So 15 minus 11 is 4. And it would actually be negative 4/16 because negative 15/16 is further away from 0. If I look at this answer, it can actually be simplified further to negative 1/4. So 11/16 minus 15/16 would actually be negative 1/4. So I know that was a lot of examples. On the next page, you have the you do problems to try. So you have a mix of integers, decimals, and fractions again. I have other videos on how to add rational numbers and how to convert, a whole lesson on how to convert subtraction problems to addition problems. So be sure to check out my channel if you needed more support on those topics. So be sure to do these you do problems and then check with your teacher for the answers. Good luck.